Alright, see? This is trichloromethane, alright? It's a polar molecule. Now, what these signs mean is, because the electronegativity difference between carbon and chlorine is more than 1.7 to 1.8, okay? Now, you have to check that fact. Now, what happens is, in the bond, this basically means chlorine attracts more of the electrons in its orbit, in its bonding orbit, more. So, the electrons will spend more time in the chlorine, causing it to be more negative. And this leaves the carbon with, with less electrons spending more time in its orbit, causing it to be delta positive, okay? Now, trichloromethane is a really polar molecule and has strong dipole-dipole bonding, alright? Now, this is tetrachloromethane. Even though all the bonds are polar, it is a nonpolar molecule overall because everywhere is fucking delta negative, delta negative, delta negative, right? This symmetry causes, all the charges to cancel out, so therefore the whole thing is nonpolar overall. Okay? Now, van der Waals is, now, you learned that van der Waals has increasing van der Waals forces as the molecule gets bigger in the case of hydrocarbons, right? So, let's take iodine and chlorine, okay? Now, the reason why halogens are more solid as you go down group 7 is due to van der Waals, okay? Now, van der Waals happens like this. An iodine molecule is two, circle-y shit bonded together, so the orbit will form like a donut-y shape, okay? This is how the electron moves around its orbit, okay? So the electrons go wee, nigga, wee, okay? Now, what happens when another iodine molecule bumps into another iodine molecule is because the electron cloud, surrounding it bumps into each other, right? Because it's a negative charge because of the orbit, orbiting electrons. When it pushes this thing slightly, due to mutual repulsion, some of the electrons will respond by moving to the other side of the iodine molecule, causing this to be really, really slightly positive. And this thing, remains its, this charged shit, right? Now, that creates a temporary bond, okay? But then it breaks off soon. That's why van der Waals is weak, because, yeah. So, the bigger the molecule is, the higher the electron displacement, causing more van der Waals bonding, and, shit with more electrons, because there's more of a temporary dipole difference. Now, hydrogen bonding is a bit weird, alright? It's the strongest of the weak intermolecular bonds. Let me draw a bracket first so it's, less confusing. Now, oxygen is, 8 protons, right? So therefore it's 1s2, 2s2, 2p4, I think. Yeah, it is. So basically these things hybridize, alright? 1, 2, 3, sp, alright? 1, 2, 1, 2, 3, 4. Now, they hybridize to form sp orbitals. You will learn that later. So, it will look like 1, 2, 3, 4. And there is 8 electrons. 1, 2, 3, 4. 6 electrons on the outer shell. 5, 6. Okay? Now, when hydrogen bonds with water in H2O, the hydrogen's electron comes over here and here, meaning this is an oxygen molecule with all its sp orbitals. Okay? Now this sticks out that way, alright? Now those are the lone pairs, okay? And these are the ones that's bonding with hydrogen. Now that is sp2 hybridized. What is sp3? I think it's sp3 hybridized. And this is the oxygen molecule. Now that is the real explanation for it. But then in layman terms, which is the one you're probably doing now, water is bonded like this. But then I'll draw the simplified structure, which is this. Now, remember the electrons are really dense here because of the lone pairs, because their freedom to rule over these orbits. All right. Now, what happens is in water, this happens. Now, again, due to electronegativity difference, most of hydrogen's electrons will spend its time over here. And due to oxygen being a really small molecule, small atom, it can pull in the electrons harder because, nuclear charge rules over distance and shielding by outer electron shells. So this will become really fucking negative. And this will become really positive. Now what that implicates is, this will be like a naked proton. And this will have a lot of electrons over it because of the non-bonding pairs as well. And to do with the bond polarity, so it's a multiplicative effect. So what happens is, the naked proton from here, which is really positive due to, most of the time of the electron spending on the water. This happens, a temporary bond will form between the oxygen and the hydrogen due to the polarity difference.